Welcome to our lesson 5. In this lesson, we're going to solve some problems involving arithmetic sequences and arithmetic series. And this is still part of our chapter 1, which is sequences and series. Let's start with our very first problem. The third term in an arithmetic sequence is 9. Its 10th term is 23. Then we have to find the 20th term. Okay. So in this case, it seems that we have our a sub 3, our third term, which is 9, and we have our n for this equals 3. Then we have also our 10th term, which is 23, and our n for that is 10. And we are tasked to find the 20th term. Okay, so we can use the arithmetic sequence formula, and that is a sub n equals a sub 1 plus n minus 1 times d. So in this case, we have, since we are looking for the 20th term, we say a sub 20. Our first term is we do not know. We have n, which is 20 for this, since we are looking for 20th term. So that is 20 minus 1 is 19d. So our problem here is, if we have the first term and we have the common difference d, we can actually get our 20th term. But the problem is we do not have the value of the first term. We do not have the value of the common difference. So that's our first goal. We will solve first our first term, and we will solve first our common difference. Then let's substitute it here. Then we will be able to get our 20th term. Okay, so how do we find our a sub 1 and d? We are going to use this information above. The third term is 9 and the 10th term is 23 to get our common difference and the first term. So we have a sub 3 is 9. Is that 9? That makes n equals 3. And we have a sub 10 equals 23. That makes n equals 10. What we're going to do is to use this to find our a sub 1, our first term, and the value of our common difference. So how do you do that? Is we simply substitute for this. We substitute it in our general term for arithmetic sequence. We say we have a sub n we have a sub n equals a sub 1 plus n minus 1 times d. This is our general term for arithmetic sequence. So we have our a sub n is, this becomes a sub 3, and that is, we do not know the a sub 1. So we have a sub 3 is 3 minus 1. We do not know our d. So we know that our a sub 3 is 9. So we'll simply replace that with 9. 9 equals a sub 1 plus 2d. This is our first equation. Remember that we are trying to get the value of a sub 1 and d. That is two variable unknowns. So that makes us to form two equations also involving a sub 1 and d. So the second equation that we're going to form is using this information. And the same principle, we'll use a sub n times d. A sub 10, that's a sub 10. A sub 1, we do not know. And we know that the n here is 10 times d, and that results to, we know that a sub 10 is simply 23. And that is a sub 1 plus 9d. So this is our second equation. So we need to solve these two equations, okay? We need to solve these two equations by simultaneously by either substitution or elimination. So let's copy first our equation 1. We have 9 equals, so this is our equation 1, this is our equation 2, okay? 9 equals a sub 1 plus 2d. Then we have our 23 equals a sub 1 plus 90. Okay, so in this case, as you can see, a sub 1 can be eliminated by subtraction. So let us eliminate a sub 1 by subtraction. So let's just simply subtract this one. Okay, so 9 minus 23 is negative 14. A sub 1 minus a sub 1 is 0. 2d minus 9d is negative 7d. So this one gives us d equals positive 2. So yeah, we have now our value of d, which is the common difference, is 2. So going back here, we have already the value of d. We say a sub 20 equals a sub 1 plus 19 times 2. So we are only left with our value of the first term. So what is our first term? How do we get the first term? We will simply substitute d here. So we say 9 equals a sub 1 plus 2 times 2. Okay, so that gives us 9 equals a sub 1 plus 4. So what must be added to 4 to get 9? Therefore, that is 5. So a sub 1 is simply 5. Oh, so we have now our first term as 5. So we will substitute our d. We substituted already our value of d. We will substitute now our value of a1 in our sequence. So we have a sub 20. This is 5. And this is 19 times 2 is 38. And yeah, we have our 20th term, which is 43. Okay? So if we have the third term in an arithmetic sequence, which is 9, and its third term is 23, our 20th term is 43. So let's proceed to the next problem. So we have here number 2. The fifth term, a sub 5, is negative 8. The ninth term is, or a sub 9, that is 4. We are tasked to find the 30th term. So we know that in this case, that is n equals 5. And we know in this case, we say, in this info, we say n equals 9. So we will use, again, our this one to if you're going to form an initial equation first on how to find a sub 30, we say a sub 30 equals a sub 1 plus 30 minus 1 times d. And we say a sub 30 equals a sub 1 plus 29 times d. So this is our initial equation. Why? Because we need to find first the value of the first term and the common difference d. So how do we do that? Is we need to find the d and the first term using the available information. In this problem, we have a sub 5 equals negative 8 and a sub 9 equals positive 4. So you have a sub 5 equals 8. That gives us n equals 5. So let's just substitute it in n, a sub 1 plus n minus 1 times d. So this is a sub n becomes a sub 5. We do not know our a sub 1. We know our n, which is 5 minus 1 times d. So that gives us our a sub 5. Okay. So our a sub 5 is simply 8. So you replace it with 8. This is a sub 1 plus 4d. And this is simply our equation 1. Then again, we'll use this information again. A sub 9 equals 4. A a sub 9 equals 4, that is apparently n equals 9. So we say a sub 9 equals a sub 1 using the same equation here, general term of the sequence, plus 9 minus 1 times d. So apparently our a sub 9 is simply 4, sorry. So we have a sub 1 plus 8d. And this is our equation 2. Solving our equation 1 and equation 2 by elimination, we have 8 equals a sub 1 plus 4d, and 4, oh, this is negative 8. And negative 8. This is negative 8. Negative 8. Okay. A sub 1 plus 8d. So a sub 1 can be eliminated by subtraction, so we need to eliminate this by subtraction. So let's subtract the two equations. So negative 8 minus 4 is negative 12, equals a sub 1 minus a sub 1 becomes 0. 4 minus um, 8 is negative 4d, and obviously d becomes positive 3. So going back, we have now here a sub 30 equals a sub 1 plus 29 times 3, because the value of the, we do not yet have our value of the first term. So we need to find the value of the first term, that is, let's substitute it here, the easiest way around. So we have negative 8 equals a sub 1 plus 4 times, what's the value of the 3? Okay, so that gives us negative 8 equals a sub 1 and 12. So here we have our minus 12 and minus 12. We have our a sub 1, our first term, as negative 20. So our first term is negative 20, and we will replace that in this one. So we have a sub 30 and r sub 1 is negative 20 plus, what is the 29 times 3? It's like saying 30 times 3 minus 3, so that's 87. Subtract 20 from it, and that is 67. So the 30th term is 67. So let's proceed with the next example. So 3. Suppose x, 2x minus 1, 3x minus 2 are terms of an arithmetic sequence. Find the value of x. So what should be the value of x? In other terms, in other words, what should be the value of x so that this x, 2x minus 1 and 3x minus 2 are will form an arithmetic sequence. Okay, so let's go back to the idea of the basic characteristic of arithmetic sequence. So by illustration, we give examples yet. So we have 5, 8, 11, and let us say 14. So this is an example of an arithmetic sequence. So we notice that if we're going to subtract 8 minus 5, it's actually the same with subtracting 11 minus 8, and enter that the same with 14 minus 11. Okay, meaning what does it tell us is that it tells us that when we subtract a term from its previous term, its succeeding term, it's the same as when we subtract again a term from its next term. Okay, so when we subtract a term from its next term, it's actually the same when we subtract any other term from its next term. So what does it tell us is that we can apply it here. The idea is we can apply it here. If we're going to subtract this one, okay, so in general, it's like in general, if we have a sub 1, a sub 2, and a sub 3, and so on, like up to a sub n, we can say a sub 2 minus a sub 1 is just the same as a sub 3 minus a sub 2. Okay, so applying this in that problem, we will have 2x minus 1, and that is subtract minus let me just then 3x minus 2 minus, we need to enclose it with parentheses because the next is a binomial. So let's just simply simplify and solve for x. So 2x minus x becomes the left side becomes x minus 1. The right hand side becomes 3x minus 2x. Let me change the third term into 2x for to avoid confusion here. Let me just change this into 2x plus 3. Okay. So this becomes 2x plus 3. Okay. So because if we're going to use 3x minus 2, that becomes 0. So no solution for x. So here we have 2x plus 3 minus 2x minus 1. So we'll have 2x minus 2x. 2x minus 2x is simply 0. So this becomes 0. 3 minus negative 1, that is positive 4. So here we have x equals 5. Okay. So the value of x must be 5 so that those terms will form an arithmetic sequence. So if we're going to substitute it, let's check. If x is 5, 2x minus 1 is 2 times 5 minus 1, that's 9. 2x plus 3 means 2 times 5, 10 plus 3, 13. So as you can see, these three terms actually form an arithmetic sequence. Let's continue. The terms 2y, 4y, and 5y plus 3 are terms of an arithmetic sequence. Find the value of y. So the same principle, let's subtract this one and that one. So we have 4y minus 2y, and that one 5y plus 3 minus 4y. So here 4y minus 2y is just simply 2y. 5y plus 3 minus 4y is simply y plus 3. Therefore y is just equals to 3. So we have here, if y is 3, 2y becomes 6. If y is 3, 4y becomes 12. If y is 3, 5y is 15 plus 3, 18. So 6, 12, 18 still form an arithmetic sequence. Number 5. So here we have find the sum of all odd numbers from 21 to 79. So it's like saying this is an problem involving arithmetic series. So we say S sub n equals n from 21 to 79. Let's divide 2. So our problem is how many terms, because we do not have our n. Okay, how many terms? So in this case we say add numbers 21, 23, 25, 27 until 29 or 79. Okay, so our next problem is what should be the value of n? How many terms are we actually adding? Okay, how many terms are actually adding? That is answerable by looking at how many terms from 21 to 79. And if we're going to count that one by one, it will take us more time. So we may try to find the value of n using our a sub n equals a sub 1 plus n minus 1. The simply general term of an arithmetic series. What is our a sub n? That's the last term, assumed last term, which is 79. Okay. Then our a sub 1 is 21, the very first odd number from that interval. Okay. Then n sub 1 is we do not know. Now, our value of these, remember, these are odd numbers, 21, 23, 25, 27. Obviously, our value of d is 2. So, we now subtract 21 from both sides. This becomes minus 21. Minus 21, that gives us 58. And that is n minus 1 times 2. Dividing both sides by 2, you'll have 29. So, what should be subtracted by 1 to make it to 29? N is 30. Therefore, this tells us, so simply again, let's go back, that we are simply using the formula for an arithmetic sequence to get the value of n. Meaning, how many terms are we simply adding from 21 to 79? How many odd numbers from 21 to 79? If the interval is so close, you can just count it. But if the interval is so long, which is for most problems, that's the case, you need to find the n using this method. So, a sub n is our last term, which is 79. 21 is our first term. Our d is, since these are odd numbers, so that is the common difference is 2. So solving the n, we got n equals 30. And n equals 30 in layman's term, in language, we say that there are 30 terms from 21 to 79. So that is simply, it's like saying us that what is the sum of these 30 terms. Okay, what is the sum of these 30 terms? So you say 30 times 21 plus 79 divided by 2. That is simply 30 this is 100 divided by 2. So this is 1,500. Fifteen times 100 is 1,500. So if you're going to add the odd numbers from 21 to 79, we have 1,500. So next problem. Find the sum of all multiples of 7 from 9 to 106. From 9 to 106. So the difference of this in the first problem is that 9 is not divisible by 7. 106 is not divisible by 7. Unlike the previous problem, 21 is an odd number, 79 is an odd number. So what we do is we simply get the next odd number right after 9, and that is 14. No. The next number that is the multiple of 7 right after 9, and that is 14. And that goes with 21, 28, 35, and so on. But what's the last number right before 106 that is divisible by 7, that is a multiple of 7? That is 105. So it's like telling us that get the sum of all terms. Those terms are all multiples of 7 from 14 to 105. Okay? From 14 to 105. So it's like saying again, S sub n, we're looking at that. Okay? We're looking at that. We do not know how many terms from 14 to 105. So, but we know that the first term is a sub 1. The last assumed term is 105 in that interval divided by 2. So again, using the same approach a while ago, we need to solve for our value of n. We need to solve for our value of n so that we can get actually our number of terms. So using our arithmetic sequence, a sub n equals a sub 1 plus n minus 1 times d. A sub n becomes the last term, 105. A sub 1 becomes 14. Okay. Then our n sub 1, n is missing. We do not know yet. Since these terms are multiples of 7, we know that the the common difference is 7 itself. Okay, so subtract 14 from both sides, so we have 91. Okay, that's 91. So minus 14, that's minus 14, 91. Then we are left with n minus 1 times 7. Okay, and then you simply divide 7 here. So we have 91 divided 7, that is 113, I guess. 1, then 21 13. So you have n minus 1. So yeah, n is 14. Okay, meaning from 14 to 105 there are 14 terms that need to be added, so that we will get the sum of all these multiples of 7 within the given interval. So it's like saying find the sum of these 14 terms. That's 7, because 14 divided 2 is 7. 105 plus 14 is 119, and that is 3 9 times 7 is 63. So that is 63, and that is 8. So 833, if that's correct. So you check if that's correct. 7 times 119. Okay, so that's it. If you're going to add all of this, we get the sum of 833 from 14 to 105. The terms are multiples of 7. So that is for problems involving arithmetic sequences and arithmetic series. There are still a lot of problems involving this sequences and this series. So these are some.